Our next speaker is Ken Horne. Ken is the Principal Engineer and Director of Multilateral Solutions in Aberdeen. He set up Multilateral Solutions 19 years ago, and during this time he's worked with and advised numerous oil and gas operators worldwide on the value of using multilateral technology, and Ken will explain exactly what he means by that if anybody's not sure. And this is used to connect small pools, increase reservoir contact. He assists and guides the companies to select the most appropriate multilateral systems, as well as supporting and advising them during the construction and operational phases. So thank you, Ken.
Thank you. Sometimes we just need to look to nature for a clue as to what to do. And this is what the trees represent, is that you very seldom see a plant just with one single root. They're all trying to get to the small pools. So we can all agree that new technology is necessary and it's exciting to be part of. However, mature technology, I believe, still has a lot to offer. There's a lot of mature technologies over the last 20 years, be it mergers, acquisitions, buyovers, companies being merged with other companies, and some of the technologies just get put in the top drawer and totally lost. And engineers like you and I might say, gee, I remember that tool, and it worked then. Why can't it work now? But what we need in this current climate is to be sure that we're using the right technology. Not just because it's going to be a sexy SPE paper, not because it's what I've done 20, 30 times before, but the right technology. So multilateral technology is not new, although some people may think it is. In the recent downturn in the industry, with the loss of many engineers, I go into companies and I look around, companies I went into maybe 4 or 5 years ago, and I know no one there anymore. They've all been promoted, they've all been retired, they've all been laid off, and you're looking around for a face that you know. And some of the people that are left, this is new technology to them. And I sometimes have to sit down with them and say, well, 10, 15 years ago, I did this well for you, and this well for you, and this well, and actually pull in files that they say, where did you find that? Well, you just need to know where to go and find the well schematics and the service company who may have constructed it for you. There's 2 patents as examples, 1931, 1938, for multilaterals. This is not new, but yet, in the UK sector in particular, we just don't use it. 1953, Alexander Grigorian from Azerbaijan drilled this well, 9 laterals, 5.5 times the reservoir contact, and production 17 times more than a conventional well. Here's 3 slides here, just different ways that you might apply multilaterals, all in the same plane, maybe 3 stacked reservoirs, perhaps horizontally opposed, dual laterals. You may have totally discrete pools with sealing faults between each other and add a lateral on, and maybe it's not necessarily drilled like this. Maybe it was drilled as a mother bore +1, and then you add a lateral on later on. Or maybe it was drilled like this, or at least prepared like this, so that you could add the lateral. This one here is quite interesting that we're using pairs, so we're using an injector and a producer. And it wasn't so long ago that I did one of these in the west of Shetland, where instead of drilling 2 water injectors and 2 producers, we just drilled 2 water injectors and 1 producer, with a leg being fed from each water injection. So what if we could reduce the amount of slots on a platform, resulting in smaller platforms needing to be built if we're still going to be building platforms, or using the existing slots that's left, or perhaps smaller subsea templates. This morning I sat in a lot of presentations where we're talking about multiple subsea templates with multiple flow lines. Maybe we could just take that down to 1 template and 1 set of umbilicals and 1 set of flow lines, yet still get the same reservoir contact per well. And we're still only having to drill fewer top hole sections. So if you're drilling in an area that has issues for drilling the top hole section, don't do it a second time. Just add a lateral to your existing well that you've just got past all the problem zones. So you could reduce the amount of Christmas trees, the amount of flow lines required. You could deploy fewer casings, less liners, less cement. You can see where this is going. It's a no-brainer. It saves you money by doing this. Reduce the volume of cuttings that you have to skip and ship and treat and transport all over the UK. And then, of course, at the end of the project, you've got less wells to abandon. So all of a sudden, the subsea, if it is a subsea infrastructure, is much smaller, and you have to do less. It costs less. And for the fishermen, it's a smaller target. Rather than 4 or 5, maybe it's 1 or 2 areas that they have to avoid. Here's an article published 2012 by Woodside, Western Australia, on the Vincent project. They drilled 13 wells, 13 upper completions, 13 subsea trees, but they had 31 laterals, cost saving $1 billion Australian dollars. That's not to be overlooked. They then also, through this project, saw very clearly that to add a lateral onto the existing motherboard they've just drilled only cost them 30%. That's a 70% cost saving on that lateral. We're not talking 5%, 10%, 70% cost saving. Halliburton, 2015, the last oil show in Aberdeen here, presented a paper, Overcoming the Perceived Risks of Multilaterals. I get it, all the service companies get it. You walk in, you're trying to sell or trying to promote a technology, and people will say, oh, well, we've had a problem, or we're not very sure, or we don't have the experienced people. And what Halliburton grasped the nettle and decided, let's review our data set. So for the last 22 years of constructing multilaterals, they set an engineer the task, go and look at all these multilateral wells. And that data set included 951 junctions and 778 wells, all different levels of junctions, onshore and offshore. And what you see here is actually, it surprised me, was from 1995 through to 2015, you can actually see the reliability success rate. It's increased, but it was never that low. The perception of it is such that people would have thought, oh, 50-50. But in actual fact, it's over 80% back in 1995. Now, there is a paper number here. I can't go into all the details on it, but it's really worth a read on the perceived risks. They also got down and drilled down to the actual root causes. And you can see some of these didn't actually surprise me. But what we've got here is 9.7% being just associated operations, the biggest one being operational decisions. One of the things that I try to instill into the operators I'm working with is that this is not going to be a drilling project and then a completions project. This is a well construction project. The whole team, from the subsurface, the driller, the completions guys, even the subsea engineers, everybody has to get on board and everybody has to play their role in it. And what you see here is that the planning, and here, the procedures, and the personnel competence is quite a small part of it, equipment design. So it makes very good reading. There was another statement in a presentation given 2015, again, by a Halliburton engineer, and I apologize for only quoting Halliburton here, but they're the only company who've been open enough, or at least first on the bandwagon, to put this information out there, to say, look guys, this is the actual numbers. Come and read it if you want to. So as of 2015 in our Norwegian continental shelf area, 240 junctions and 165 wells. And the associated cost to add a lateral to a motherboard was 27% more. So again, 73% cost saving. That lateral is costing you 27%. So I firmly believe when we get into sitting down with operators and planning with the teams, they all start to get oh, we need all these whistles and we need all these bells. It's like going into the car showroom and ticking all the boxes for all the fancy wheels and the fancy leather, and then you see the price and you go, well, actually, maybe I don't quite need that. Maybe it just needs to be fit for purpose. But I believe that not every multilateral well, like something, has to be Einstein smart. It just needs to be smart enough. Now, what I say by that is that if it's a land well or a platform well, we don't necessarily need fiber optics or hydraulically operated control lines to open and close sleeves. We can do that with slickline. We can do that with coil. We can even, I've been doing some trials just recently with electric line tractors where we're actually going to be running to over 5,000 meters to manipulate sleeves, to actually drill out particular portions of the well construction. So we've already used that technologies. We just need to be smart enough about it, because when we add all these whistles and bells, guess what? The costs increase. So multilateral drivers, increased reserves, obviously. If we're saying that it only adds 30%, we've got a well here, we might have drilled for 40 million, a well here for 40 million. And this one here, we're just adding 30%, 52 million. We may have doubled the size, the reservoir contact, from that one well, from that one slot, from that one tree. Marginal reserves, stacked and compartmentalized reserves. So we can use multilaterals for lots of things, even water injectors. I'm looking at one right now where we're looking at producing from one pool and injecting water into the other pool. So where can multilaterals be used? Obviously, small pools fits here today. Tight rock, stacked and compartmentalized reservoirs, and pools that are just impossible, no matter with the technology that we've got today for directional drilling. We just can't reach all the pools, and they'll just lay there dormant because we're never going to drill a single well to that one pool. Saudi Aramco came to Aberdeen in 2011 and shook the tree a little bit. They have been well known for drilling wells where they call them MRCs, maximum reservoir contact. But they have been and are pushing the envelope to get wells of up to 25 laterals, so extreme reservoir contact. This is active projects going on. There are many wells in their portfolio that have more than 5 or 6 or 7 laterals. So the drivers, obviously, or at least to me, using less slots. Increase the reservoir contact per well. Exploit and access the smaller pools that we're talking about today. Generate less cut-ins, less cost to dispose and transport. And reduce costs for the casing and cementing. When you're talking about an ERD well, it might even be that the reason you don't do an ERD well is because you can't get all the casing on your platform. So if you're looking to actually reduce casings and cementing, you can do all this with multilaterals. But you can also do ERD multilaterals, which is something that's ongoing at the moment. So using fewer wellheads and subsea trees, and even use these wells is to plan them up front. Plan them up front to know what you want to do with them in their second life cycle, or even third life cycle. You might be able to, and I've been working with a client in Germany where we construct high-level, high-pressure, level 5 multilateral junctions, producing from both legs. And the second life cycle is, once they're producing a water at a certain rate, we pull the ESP pumps out, we slide in a very simple completion, and we start pumping water to both legs. And we're just working in a circular motion further and further and further away from the drill center. And what a lot of people don't take into account is they think, oh, a multilateral, you must drill a multilateral from new. Well, a lot of them are. But there's also a lot of wells that are applicable and have had laterals added to them. So it has an existing well. It may be low pressure. It may be low rate. It may be under consideration for abandonment and doing a sidetrack. But why abandon it if you could just suspend it and leave that gas and oil in place and leave it to supercharge for 2 or 3 or 4 or 5 years and produce the lateral on its own. This has been done in the southern North Sea over 10 years ago, very successfully. So here's some data on multilateral junctions from an ERD perspective. The 4 main service companies who have developed the equipment and have the technology to be able to construct multilaterals. You can see the measured depths at the junctions. The world record being 6,950 meters measured, and there's an SPE paper on that. And I'm currently working with a German client who's planning an ERD multilateral. In fact, Ian with Merlin are working with the same client on that ERD wells, and the junctions are going to be at 5,100 meters on the first one and 6,200 meters on the second one. One of the engineers said it's a little bit like doing brain surgery with barbecue tongs. You're not quite sure what you're doing, but we've been building up to this. You just don't all of a sudden decide, I'm going to do this. For the last 3 wells, we've been trialing techniques and using existing technologies to enable us to get to this point. So we've been using some downhole drilling tools that you would be able to give you weight on bit, vibration, pressures whilst you're drilling, and we're actually using them for setting whipstocks and milling windows, because the drilling engineer on surface on the break and the milling hand out there doesn't necessarily know when he picks up 2 or 3 meters. Nothing's happening downhole at 5,100 meters. But the tools are there. You just have to cherry pick some of them and not just say, oh, we need new technology. Well, it already exists. I'll bolt this to this and I'll turn this upside down and I'll do this with it. And that exists right now. This is the world record SPE paper on that, and the junction, 6,950 at the junction. So they set the whipstock, they milled the window, they ran the lateral junction, they constructed the level 5 junction here. Almost 7,000 meters. Yet we don't do this in the North Sea. There's something happens when you fly from mainland Europe to the UK. There's something, and I don't know what it is. So multilateral technology is not only applicable to new wells, it can be added to existing wells, as I say. One client that I have in Europe is having some environmental issues with their land wells, where nice wells have been producing for a very long time, but they're in very environmentally sensitive areas, and they're not allowed to drill another well. But they are allowed to go into the existing well, and this is where we're talking. We'll go in and we'll add 1 lateral. Maybe we'll add 2 laterals. And we're not impeaching on anything they don't already have. But we're not scarring the landscape with more and more wells. We're just using what we've got, being a little bit more clever about it. So I would suggest that any new well be constructed in such a way to allow the addition of a lateral. And that's really just low-cost, high-value things, getting the cement in the right place, getting the centralizers in the right place, and getting the tangent in place. Several analog wells, as I alluded to earlier, where we basically took an existing well, and we didn't kill it. We just suspended it, pulled the completion, run a new completion, and add a lateral, and producing the lateral on its own for over 3 years, and then bring the motherboard back on again. So it might be possible to imagine that one operator constructs and owns 1 leg of a multilateral, whilst the other leg is drilled perhaps ERD into another lease, across a lease line, and funded and owned by another operator or financier, yet drilled, constructed, and produced to the same platform. Maybe this is one version of collaboration in the future in our industry. And we're back to nature with the tree versus the multilaterals. Thank you.